Okay, so good afternoon, London. It's nice to be back in the homeland. That was a very weak response, but okay. Thanks. Yeah, so today we want to talk a little bit about Wolframite and how this brings potentially more computational intelligence to Clojure. So, first things first, speaking of intelligence, I would like to introduce Jakub. Jakub, who are you?
Hello, welcome. My name is Jakub Holý. I'm Czech, living in Norway, a professional developer of many years, and I have been interested in data science for quite a while. And I discovered Wolfram a couple of years ago, and I have been absolutely mind blown by its capabilities and some really unique features of it. And I'm very happy to be able to share it with you in the form of Wolframite. And I work for a Norwegian scale-up called RDoc.
Thanks, Jakub. Okay, so my name's Thomas Clark. Actually, as of a few weeks ago, I am now a Scottish-Hungarian citizen, which I guess for a London crowd can be translated roughly as troublemaker. But other than that, I'm a professional physicist, so I'm kind of interloping in this conference. And so really my motivation with Wolframite is that really I just want to get stuff done. So, speaking of getting things done, we want to thank Clojurists Together, who gave us some short-term funding to get this project on the go again. And I also want to point out that this project has been going on for decades now, actually. And so, really, these are the main people that you should thank for what came. Okay, so this is the Clojure conference, so, I have to give you some definitions. So our dictionary for today, which is not in Latin, just so you know, is what is Wolframite? Why is Wolframite? And hopefully, we're going to break this down into two parts. The first part is, why is Wolframite for a developer? Why is Wolframite for a scientist? And then at the end, if I don't talk too long, we can have a demo, how to Wolframite. And I know this is not the normal Clojure talk, so I also wanted to say there is a coffee break coming up for those who need some hope. Okay, so what is Wolframite? Well, I don't know actually if people know, but these days there is a technical tool for finding out these things. You can go onto Wolfram Alpha and you can type Wolframite. And what you find out is that actually it is a mineral. In fact, Wolframite is mostly made up of tungsten, which is a very useful metal, which is mostly useful because it's very dense and very hard and expensive. It actually also has iron, which I don't need to explain. And it also has manganese. So manganese, for those who don't know, is actually something that appears in supplements because it's actually good for you, and it tarnishes slowly. So this is the mineral Wolframite. Aren't you glad you came? It's like, you never know what you're going to learn in a Clojure conference, so why is this relevant? And it's like, so fundamentally, I thought this was a good analogy, because I think, if you go out into the world, you don't find just chunks of tungsten or chunks of manganese lying around. The real things that exist, which kind of survive through time, are actually composites. And so, what is a mineral? So a mineral is a reminder that the whole is greater than the sum of its parts. And I think this is something, I'm not an engineer, but I assume that in engineering, this is really important. It's like if something is designed really well, it doesn't matter if it's expensive or doesn't work. And so fundamentally, I think Clojure gets this balance right between being quite an idealistic, nice language to use, but also realistic. And so if we answer this, so we can be more specific, what is Wolframite, the project? And so really it is this. So as you can see, with some apologies to the Wolfram team, we want to combine the best of Wolfram, which is somewhat dense, with the ecosystem of Java, and we want to access it through Clojure, because it's scientifically proven that Clojure makes you happy. Trust me, I'm a doctor. So I also want to point out that this is just one tool in the scientific Clojure stack, which has advanced a lot in recent years. And so I really advise that you check it out. But fundamentally, I know that for many of you here, we need to ask the more fundamental question, what actually is Wolfram? Has anyone used Wolfram before? Oh, that's a lot more than I expected. Okay, maybe I don't need this slide, but so I need to reference Wikipedia though. And so if we go to Wikipedia and we ask it, then fundamentally what we find is that Wolfram is a general purpose programming language, which of course is not very interesting, at this kind of conference. But it's interesting when you start asking, what does general mean? Because before the large language model revolution, Wolfram was already selling itself as computational intelligence, as a type of computational language. And what it means by this is that it tries to combine active access to knowledge databases with AI, number crunching, and symbolic manipulation, particularly when it comes to maths. And actually, this makes Wolfram an incredibly flexible language. And this allows us to define, so why is Wolframite, as a Clojure library, why do we have this? Well, I would say that Wolfram itself combines the flexibility and power of abstract mathematics with the intuitive clarity of abstract mathematics, which is a slight XKCD paraphrase for those who know. And part of the problem of this is, of course, we're not all mathematicians, are we? Are we, Jakub?
No, you. So why should you, as a Clojure developer who might not know much about data science or science and maybe never has heard about Wolfram or actually has, be interested in Wolframite or even be excited about it and thinking about ways to use it in your next project? So I would like to demonstrate that. Of course, it doesn't work, but I have a backup. So if you watch this video that was supposed to play while we were playing, yeah, it was supposed to go somewhat faster. But anyway, we have a dog here, and there is a rectangle around the dog. Originally, the movie only had a dog and no rectangles. Goodbye. And we made this new video through the code here on the left side that I will explain briefly. So we first import the video as a list of images, essentially the frames. Then we call the image bounding boxes function and tell it to please find all the concepts of a dog moving in those or present in each of the images. And finally, we export a new movie, the one we have seen, where we highlight every part of every frame with the box that was found around the dog present there. And that's the new movie. This is, of course, Wolfram. We could write the same thing in Wolframite. It's somewhat longer, but hopefully also more readable to a Clojure developer because it doesn't use so much dense, shorthand Wolfram syntax. But I don't really want to focus on this, just wanted essentially to demonstrate that it's possible and not too difficult. What I want to focus on here and highlight is that what Wolfram gives to us. It gives us very high-level functions, such as the image bounding boxes function that does object detection in images. It gives us smart and generic functions, such as import and export, that you can use to get into and out of Wolfram essentially any data you might want to work with. And they have tons of options so that you can influence how you get data in, such as we wanted just the frames, right? And it has this built-in knowledge base that was mentioned. In this case, we are using the entity representing the concept of a dog, which knows a lot of things about dogs, including how to recognize a dog in an image. And something I find rather unique about Wolfram is that all these features can be seamlessly used and combined together. So here we map image recognition of a concept over a video. And all of this in just 3 lines of code. And this is absolutely mind-bending to me, right? 3 lines of code. I cannot imagine how much code it would be in anything else, at least if I try to write them. I don't think ChatGPT would do much better. And if you are good at maths, which I suspect some of you are, you actually notice I had more than 3 lines of code, but that was just because I had very tiny horizontal space. And this is just one tiny example of what the Wolfram can do. So let's look at another domain, namely geography. So here we are interested in visiting all European capitals, and we don't want to spend too much time traveling, so we want to find the shortest path between them. Let's pretend we don't know how to get the information about the capital coordinates from Wolfram. So we can actually ask Wolfram to help us. We can give it a free-form input and use the semantic interpretation function to give us back the data we are interested in. We could also actually ask it instead to give us the corresponding code if we wanted to. So we have the coordinates, then we find the shortest tour through them, and we plot them on a map. So what I want to highlight here is that we can, among other things, use natural language input and get out code or results, which is super useful, especially when you are new to Wolfram and you don't really know how to do stuff. You can ask Wolfram to help you. We have again been using the built-in knowledge base, this time to get the entity of Europe and the countries in Europe and their capitals and their locations. I don't know about any other language which has built-in knowledge base like this. And another high-level function, the find shortest tour. I believe actually that might be NP complete problem, so Wolfram has to have some smart heuristics to actually give us results in reasonable time. And there is built-in plotting, 2D, 3D maps, so the whole stack. These were just a few examples of what Wolfram can do. So we have seen video manipulation, we have seen object recognition. I guess that falls also under not LLMs, machine learning. We have seen geography stuff and some graph algorithm. But Wolfram has actually data about social, cultural languages, about all possible sciences, and of course it can do high-level math and physics. It can work with sound, video, text, language, essentially anything you might want to work with. Wolfram is something for you. And that's true for us developers. It's even much more true for scientists.
Okay, thanks, Jakub. So I feel like I maybe have the short straw in this talk, because I have to explain why is Wolframite good for scientists to a room full of programmers. But I hope that I can answer this in a general enough way that it's at least meaningful to many of you, particularly if you do research in some form. Okay, so why is Wolframite good for scientists? Well, fundamentally, I have 3 points. Sometimes, Wolfram is just better than the other options. And sometimes this includes Clojure, I'm afraid to say. But thirdly, I want to say that Wolframite, which is combining Wolfram and Clojure, may actually offer more than just Wolfram itself, or at least sometimes. So, why or maybe when is Wolfram better than the other options? Well, we don't have so much time, so the fastest way to prove this is just to think of this situation, symbolic functional programming. And it's like, if you have to do this, what are your best options? Like if you're a scientist, you might reach for Python and, the SymPy library. But fundamentally, although this is a good library, you end up just fighting the language. Python wasn't designed for symbolic manipulation, and so it feels very unnatural. You're fighting the defaults. So it just doesn't work. And in fact, at least, in the long term. So I don't think it's future-proof. Whereas Wolfram, in contrast, it was actually designed, like for the past 40 years, from the ground up, to deal with symbolic functional programming. And so, as far as I know, anything else I've compared it to, it's just best in class for this type of problem. So, how does this affect Clojure? Well, actually, if we consider the same situation, symbolic functional programming, we know that Clojure is good at functional programming, but it's not as obvious an answer as it used to be, because in Clojure we now have this amazing computer algebra system. It was written not just in Clojure, but also in Clojure script. And this is pretty unique as far as I know, that you can now transfer these symbolic expressions between client and browser fairly seamlessly. So I'm very excited for this library. And then when it comes to kind of more numerical functional programming, then we now have a lot of tools available in Clojure, which I think we should take seriously. Like, I think they are genuinely very useful. But But fundamentally, of course, there are just some times when there are missing features. Wolfram has millions of dollars behind it. And so, yeah, there's going to be some times when there's just stuff missing. Another reason for when Wolfram is often better than Clojure, and it's a little bit more controversial, is that sometimes it's just easier. I know we like simple more than easy, etc., but for instance, when I wanted to import an HDF file, I was very happy in Clojure that I could drop down to Java to do that, but no one would really argue that this is easier than import HDF file. And this is, I think, a representative sample of the way that Wolfram works with these situations. And actually, for scientists, this is, the simple level of API is what's good for us. But, I understand, though, that maybe you don't really care. It's like, okay, it makes scientists' life easier, so how does it affect me? And really, I think this is practical. There are practical reasons for being easy, particularly when it comes to prototyping. I think one part of the theme of this conference is innovation. And so when it comes to prototyping, I think being easy is very useful. In fact, if you wake up one morning, as scientists do, and you say, okay, I want to take a picture of an object, but I don't want to use a camera. So, well, I could use a projector instead, which is what this DMD thing is for. And so what do? It's like, well, I go to this website, which collects together strange mathematical algorithms, and then I'm very happy when I realize that the same people who collect together these very niche situations actually made a programming language. And so there is just a function for this very obscure piece of mathematics. And Wolfram has close to like 7,000 functions, and they're all global. We'll get to that later. But and it's nice that they're just there. You don't have to download anything. You don't have to find the package. And you could argue that, okay, you could have implemented this in Clojure, and maybe it would be faster and better, whatever. But actually, when you're moving quickly, when you're wanting to test ideas, then the fact that it's just there is definitely an advantage, because you want to get to the end of your ideas with as much momentum as possible. So I think Wolfram, just for when you're playing with things, is still a very useful tool to have. Okay. So this brings us to Wolframite, the wider library itself. When is this better, or does it offer more than Wolfram? So the context here is that Wolfram is pretty comprehensive. Like if you're working in a small to medium size, science problem or data science problem, then it can really do everything, particularly if you have the desktop environment. And the API is consistent, which kind of makes it quite unique, because whether you're plotting 2D data, 3D data, 4D data, it's the same API. And this doesn't happen very often. But I think it's fair to say that, like any language, it can do, almost everything, but it's not the best at everything. And I think it's also fair to say that Wolfram is not a normal programming language. Nobody, I think, in this room is going to wake up tomorrow and say, I want to build a website, so I'm going to turn to my favorite abstract maths engine. It's like, it's not really going to work. And so I think for me, what this means is that Wolfram is a very powerful tool, but it's better if it's embedded inside some toolbox. And so the real question for me was, well, what is actually the best language to access Wolfram from? And so if you go through the Wolfram doc, what you find is that Wolfram says that the best language to access Wolfram is Java. But when you find out that Wolfram on the inside is actually a functional Lisp, then maybe what we really want is a functional Lisp connected to the Java ecosystem. It's like, fill in the blanks. Okay, so there are other practical reasons. Okay, Wolfram can be used for just about everything, but for those things that it can't be used, then combining the two ecosystems together, having the whole Java ecosystem and whatever else you can access through Clojure is also a real advantage. But then there are also the kind of everyday situations. Like, for example, these days you can download the internals of the Wolfram system for free for most situations. But the downside of this is that you're missing a front end, or at least some way to connect to it. You need your own editor and all these kind of things. And in this situation, I think Wolframite does actually offer you a way in to using Wolfram for free. It can be used after your license runs out. It can be used when you move jobs and there's no budget for software. And I mentioned these 2 points here because both of these happened to me. So it's a real-world situation. In fact, the license ran out when I was preparing for this talk. So that was a very meta situation. So yeah, so it can be useful, particularly if you're feeling Scottish. So just to more fundamentally, I want to mention namespacing because, brace yourself, this is a room full of programmers. But Wolfram, as I mentioned, has like 7,000 functions, but they're all global. It has the kind of Emacs philosophy to how you organize the code. And in fact, if you import packages, they don't get put in their own namespace, or at least not without difficulty. They're also global. And this gets tiring very quickly. Whereas in Wolframite, we can use the Wolfram syntax. We can import any sort of Wolfram code or library into the Clojure system, and you just close your eyes and pretend you're typing Clojure. So I think this is great that it just works. And also this works when it comes to auto-completion and documentation, so I think that's a win. Fundamentally as well, I think customization is a big advantage of Wolframite. So this is something that Jakub and I put a lot of effort into. Like, I just want to mention that Jakub is the brains behind the operation. So I have a big shout out to him when it's live and he can't correct me. So, and just to give you an example of customization, you can do something simple like just rewriting the language terms, which in a mathematical context is in itself useful. Or you can do metaprogramming. And so if you take what would be the standard way of representing maths in computers, then of course a couple of lines, in fact one line minus documentation, etc., of Clojure macro, suddenly you can extend the language and use threading macros. And interestingly, I genuinely believe that this is a better way to think about maths, because to think it through logically in a threading macro is closer to how people really think. So for me, this is also a big win. And lastly, I just want to mention interactivity. And for those of you who don't know much about Wolfram, this is a strange thing to say, because I think it is fair to say that Wolfram, probably more than any other system, really pioneered making maths interactive. So it was really, really incredible what they did with it. But the problem, in my view, is that they went down this route of notebooks. And notebooks have advantages, but they also have a lot of disadvantages. In the Lisp world, when I discovered it, I was very happy to find out, in the Lisp world, people are used to this idea that you can build big enterprise systems, but then you can still evaluate things at the level of the individual expression. And of course, this is something we barely think about in Clojure, but this doesn't really work in Wolfram. And so this, I think, really does add to the experience, if just by being able to put it through a REPL, which is sort of a boring thing to say at a Clojure conference, but it's still true. OK, so speaking of interactivity, I think we do have time for a demonstration. So, Jakub.
Thank you.
Sure.
Thank you. Before we get to that, a little of context. So when you actually start Wolframite, it obviously runs in JVM, and it starts another process, Wolfram engine, which means you have to get Wolfram or Mathematica first and then set up them and so on. And it sends Wolfram expression as Eden data, and then gets response back, essentially. And sometimes Wolfram engine talks to the Wolfram cloud as well, because some parts of the knowledge base are not available locally, and some functionality also needs to run in the cloud, but mostly it just is on your computer. So let me switch to here. So this is part of our docs, our quick start. So the first thing we need to do actually is to start Wolframite, which in practice means it will find your local installation of Wolfram engine, start the process, and set up the communication. And then we can go on and actually evaluate some Wolfram. So here we are making dot product of two vectors. We could write the same thing using one of the aliases that Thomas introduced, which happens to be more readable if you are by chance a physicist. We could actually do the same thing and just paste in raw Wolfram as a string, which is super useful when we just get some piece of Wolfram from the internet and want to run it. we actually have a function that can help you translate that Wolfram code into Wolframite. And here it might be better to look down here into the REPL output. So that's what it would look like in Wolframite. This is a symbolic form, but symbols are hard to work with and compose. So actually for each Wolfram symbol, we have a var. So the way you would actually use it is this one. And if we try that, we translate back to Wolfram, we see that we get the same thing that we had before. And when you are, so yeah, you saw that we have some doc strings that you can refer to, but actually we can also ask Wolframite to help us and open the documentation page, which doesn't work, but I have a backup here. So each function has a page in Wolfram documentation, and there is a lot of details about all the options. There are examples of how to use it. There is related things. It's super useful, very valuable. So it's good to be able to get to it easily. And actually, the help function can take a whole expression, and it opens a web page or gives you a link for every of the Wolfram symbols that is there. And the last section, I want to show you that you can show things. So in this case, actually, we get back HTML because, as mentioned, so this is part of our documentation, which is rendered as a notebook using Clay into web page. But that's not so helpful right now when I'm not using it as a notebook. So here I will actually use Java to display the thing. And here we have a beautiful window. Let me make it a little bigger. So maybe grids are not so exciting, but we can also display other interesting things. Here we actually use the built-in knowledge base to find out what is the structure of ethanol and displaying it. We can even display such a thing as the structure of a piece of text. And since we have this abstract math engine, as was mentioned, we can work with curves, we can combine them with entities, and I made the window too big, so let's fix that a little. I think it should be like this. Yep. Mm-hmm. Yep. And there is more in the demo, but let's get back to the presentation. Oh, come on. So it doesn't work when I have internet, but I guess I could actually use my fallback. Where is the PDF? In documents, of course. Documents. No, it's not here. Ah. Anyway, there's not much more. I could at least go to full screen. So these are the functions that you need to know, essentially. Start Wolframite, translate things into Wolframite version from Wolfram, evaluate the expression, which actually means sending it over and get results back, and help. And as mentioned, we have this namespace with vars for all those 7,000 plus functions and other things in Wolfram. One thing I really want to mention is that we have put a lot of effort into our documentation, which is absolutely worth checking out. And as mentioned, so actually each of these pages is originally a Clojure namespace rendered as a notebook. So all the code you see there has actually been run. And we have different levels of documentation. Like we have the starting documentation, like the quick start and readme and so on. We have also very deep dives where we actually are trying to use Wolframite to solve some problems, such as cavity physics or analyzing some data. And we have also guides for people who are either new to Wolfram but know Clojure, or know Wolfram but don't know Clojure. So please try it out, spread the word, and iron sharpens iron, so let us know. And thank you.